Right, so this is section 5.5, and this is how you're going to read and write scientific notation. So take a look. I'm actually on page 351, and it says here in the book, I'll read it to you, powers of 10 are important because they are used in science to express numbers that are either very small or very large in absolute value. So here's the table. So take a look. Here's how we look. So if we have 10 to the third, that's 1,000. 10 to the 0, of course, is 1. And then when we have negative exponents, then the numbers are getting smaller because 10 to the negative 1 is really 1/10, right, or 0.1. And 10 to the negative 2 is really 1/100th, which is 0.01. So this is important to see that, and here we name it. So if you don't know the names, they're refreshing you on the memories of the names of these particular numbers. And then over here to the left is an important piece for the calculator. Notice that they talk about calculators make use of scientific notation. Okay, so the letter E denotes a power of 10. That is 2.5 e to the 13th is really 2.5 times 10 to the 13th. Or if you say 5e to the negative 6, it really means 5 times 10 to the negative 6. So let's take a look at that on your calculator. So I'll pull the calculator up, and if you turn it on, you can see where these are located. That's right here. Weak on the TI, they call it the EE. So when I hit second and the comma, you just get one E, even though there's two here. And so if I wanted to, I could do an example. So I could go 2.5, right? And then I would hit the second E, and then I would type in, let's say, a 2. And so what does that give me? Well, that's 250. So this 2 is 10 to the second power, which causes the decimal to get moved to the right 2 places. That's why you get 250. Now, if you want to work in scientific notation the whole time, there's a way to turn that on, and so it'll set that way. So if you go to the second button, right, and go to, actually not the second button, you just hit the mode button. If you hit the mode button on your calculator, you see that it's blinking on normal, and the SCI, scientific, is the other one. So you move it over to that one, and hit enter, and now it is blinking on scientific notation. So hit second quit, and so now when you do the 2.5 to the second E of 2, it's going to stay at the same way. So it's not going to change like it did here. So when we say 250, that's standard form. When we say 2.5 times 10 to the second, that's scientific form. And so you have to be able to move back and forth between standard form and scientific form. And so that's what this section is all about. So example, here's a gigantic number. Okay, it's 5,80, and then it has 3, 6, 9, 12 zeros following it. So we don't want to write all this. This is a big number. We don't need to do that. We can write it in scientific, and it'll take less space, and it's easier to actually use. So this would be a big number, so that makes it 5.88 times 10 to the 15th. So if you count, you have to start here at the decimal, where the decimal would be sitting, and you move it. So here's 3, here's 6, here's 9, here's 12, there's another 3, that makes 15. So it's moving by 3's. And we always say 5.88, or we always have a number that has to be between the 1 and less than 10. So on this next example, we have 0.00. How many zeros are there? There's 1, 2, so 1, 2, 3, 4, 5. So there's 5 zeros, and we have to go beyond the 4. So we go to 4. Go to the 4. And so this is really 4.68 times 10 to the negative 6. So this is a very small number. The negative symbol tells us that it's super small. It's not big at all. Okay, so here's the rule that we want to write down now. So let's switch back to the notes. And so we put this in our notes. So scientific notation. So scientific notation. Okay, it's a real number A. Okay, the A is a scientific notation when A is written in the form. So this is written in the form of B times 10 to the n power. Okay, where B, this B right here, has to be a number that could be 1 or it can be greater than 1, but it can't be bigger than 10. So that's what this is saying. So B can be 1 or greater and up, so up to 10, but not include 10. 10 cannot be used in scientific notation. You'd have to say 1.0. So let's take a look at some examples of these problems. So I have 5.23 times 10 to the 4th power. And I want to change this. This is scientific. I want to change it to standard form. Okay? So standard. So that means I'm going to take the decimal and move it 4 places. So let's copy it down here. And we'll move it 4 places. 1, 2, 3, 4. So here's where the new decimal place goes. And all the blanks are where zeros go. So this is really 52000. And so it's 52,000. Okay, let's take a look at another one. 8.1 times 10 to the negative 3. Okay, so what will that look like? Well, this is a negative symbol, so that means the decimal goes to the left. So if I have 8.1, it goes to the left 3 places. 1, 2, 3. And the decimal place is here. So 0, 0. So this is 0.0081 to show you the standard form. Okay? And then if we look at 6 times 10 to the negative 2, okay, the decimal place is automatically here. Okay, so here's my example. So this is small, so I'm going to go to the left. 1, 2, decimal here. So then my answer is, in standard form, 0.06. Okay, so we should be able to go back the other way as well. So let's say we have a number like 3200000. Okay, and I want to change that into scientific. Well, the decimal place is always at the end. Okay, and we count. Count 1, 2, 3, 4, 5, 6. We always stop at the last number in front. So that's 6, right? 1, 2, 3, 4, 5, 6. So that'll be 10 to the 6th power, and it's 3.2. So this is a big number, so that means the exponent has to be positive. How about if we go with a very small number? Let's go with 0.000096. Okay, so now I'm going to the right to put it in scientific. So I count 1, 2, 3, 4, 5, 6. So that means it's 9.6 times 10 to the negative 6. And so this is how you convert back and forth. And so that's some of the examples that you do in the homework. Okay. So notice though, you want to make sure that the B here is always 1 and no greater than 10. Okay, can't be 10 or anything bigger than that. So it can be any number in between. That's what the b has to be. So that's how you determine that. So now let's take a look at some problems. Let's say that you have, let's say, yeah, let's say that you're doing this one here, 3, 2, 1, comma, 0, 0, 0, comma, 0, 0, 0. So if this is a big number, so it's going to be 10 and it'll be a positive exponent. Okay, so I count because my decimal place is here. So here's 3, here's 6, 7, 8. So this would be an 8. And then this would be 3.21. On the calculator, you would type it as 3.21 E. The buttons that you'd push is EE, and then you would put an 8 in. So this is how the calculator takes it. Okay. If you have 0.001, this is a small number, so I know it's going to be times 10 to the negative. So I'm going to count it 1, 2, 3. So I know this is 3, and it's a 1.0, or just 1. You could write it this way too. On the calculator, you would type it as, oh, that's wrong. That's wrong. Okay, it would actually be a 10 there. On the calculator, we type it as 1e to the negative 3. Alright? And that's how you do these types of problems.